In this example, we are going to use the Thevenin's theorem to find a V0 in the network. The idea is that we're going to simplify the rest of the circuit to be its a Thevenin equivalence. So eventually the circuit will become something like this, with one Thevenin voltage source VTH, one resistance RTH, then in series with this resistor 4 kilo ohm, and we are looking for V0 from here. This is our idea. So after we get a Thevenin equivalence for part of the circuit, then we can use the conclusion that we got for voltage divider circuit to find a V0. So step 1, we're going to find a open circuit voltage, VOC. So over here you have many different ways that you can solve it. You can use the knowledge that we learned from chapter 2, or simply the definition of a VOC. Or you can use the knowledge that you learned from chapter 3 to calculate the voltage. Let's say if we pick this node as reference node, and we know that VOC simply becomes the nodal voltage VA minus the nodal voltage VB from the definition. And a VA, that can be calculated from the left half of the circuit. And here we have a voltage divider circuit. So we know that a VA that is equal to 6 over 6 plus 3 times 12. And a VB can be found from the other half of the circuit. Pay attention that this current that goes in the reverse direction as how we define a VB compared to the reference. So VB that is equal to negative 2 times 2 kilo ohm. So in total we have 12 volts. Second step is to find either a Thevenin equivalent resistance or the short circuit current. Since this circuit only have independent power sources, we can find RTH directly by setting all the power supplies to be 0. Note, this method only applies to circuits that has only independent power sources. When we set the voltage power source to be 0, it simply becomes a wire. Then we copy the rest of the circuit. This is 6K. And when we set the current source to be 0, it will become an open circuit. So on the right hand side, we only have this 2K resistor. And this is how we find RTH. So RTH that is equal to 3 in parallel with 6 in series with 2. So that is 4 kilo ohm. Step 3, we're going to redraw the circuit by using Thevenin equivalent. Now the new circuits become using Thevenin's theorem. We get the equivalence circuit, which is VTH here, RTH. Same time we have another resistor, which is a 4K, and this voltage is what I'm looking for. So we find a V0 that is equal to this 4K over the overall resistance 4 plus RTH that is also equal to 4 times VTH 12 volts. So that gives us 6 volts.